for each one of our quadrilaterals here, as we go through and we write down the properties, we're going to mark in the picture, good morning. We're going to mark in the picture everything that is exactly the same. So we're going to mark all of our congruent pieces. So we'll mark our sides with tick marks. We'll mark our angles with arc marks. And then we will also draw parallel sides using the arrows as well. So we're going to start with parallelogram, and we're going to kind of jump around a little bit. So just make sure, excuse me, you're following along. And again, they are doodle notes. So if you want to do it color coordinated or color coded as you work through, you're welcome to. If you want to color while you're working through, that's fine as well. It's supposed to be like a really chill way to take some notes. All right. So a quadrilateral, first of all, is a polygon that has 4 sides. So everything we're talking about today is going to have 4 sides. The most general type of quadrilateral is called a parallelogram. So it's almost like the big umbrella is parallelogram, and then everything else we talk about is kind of a different type of parallelogram. So this is like my overall reaching classification, and everything else is more specific based on that. So a parallelogram has 2 pairs of parallel sides. 2 pair of parallel sides. So if they are parallel, how do I mark that in the picture? What should I put? What's the marking for parallel? Do we remember? Oh, tick is congruent. Close though. No one? Anyone? Two lines again would just be like congruent symbols. Oh, so 2 lines is if you're saying like this is parallel to this. Yes, it's 2 lines. That's right. But what is it on a picture? It's an arrow. Yeah, an arrow. So to show that 2 sides are parallel, I just draw arrows. So 1 pair of arrows for one side. And then to show the other one, I would put 2 arrows. And it doesn't actually matter like which way your arrows are going. So if yours are going the other way, that's cool. You just need to be able to say, hey, here's 1 pair of parallel sides. Here's a 2nd pair of parallel sides. Okay, in a parallelogram, opposite angles, so that means angles that are directly across from each other, they are congruent. Congruent. And what does the word congruent mean? 2 things are congruent. They are the same. They're equal to each other. How do I show that angles are congruent? What would be the marking for that?
Curve.
It's a curve, exactly. So it's like a little arc mark. So 1 pair has 1 arc mark, and then my 2nd pair should have 2. And it doesn't matter where you put them, right? So if you put these have the 1 and these have the 2, that's fine. You just need to have 2 pairs to show that they're different. Okay. Opposite sides, so these 2 sides that are right across from each other, they are parallel, which you can see, right? They're never going to touch. They're never going to intersect. So they're parallel. And they are also what? What do you notice about them? Not only are they parallel, but they're also what? They're congruent. Yeah, they're the exact same length. How do I show that 2 sides are congruent? What should I put on them? Curves are for angles. What's for sides? Tick mark. Yeah. So I'm going to do 1 tick mark for 1 pair and then 2 tick marks for the other pair. Again, it doesn't matter if you did these had 2 and these have 1, doesn't matter. As long as you're showing they've got 2 pair of congruent sides. So knowing what each of those symbols is just by looking at the picture is super, super important. Because a lot of times you'll get a picture like this, but I'm not going to have all the words, so you have to know what the pictures mean. Okay? Next one, diagonals bisect each other. What does the word bisect mean? cut in half. Perfect. So a diagonal is when you go from one vertex to the vertex opposite of it, which is why you have a ruler. We're going to draw in our diagonals.
Thank you.
Thank you. Okay. All right, so we're going to draw in our diagonals. So from one vertex to the opposite vertex, that's one diagonal. And then the same going the opposite way. Doesn't have to be perfect, but as close as you can get it. And then if I were you, if you're going to color code your diagonals, I like circled my word diagonal in the same color that I drew it in. So that way I can look back and I go, oh, I know that that's a diagonal. Okay, so bisect means cut in half. So where these two green lines intersect right in the middle here at this point, I've got two pieces that are now exactly the same. So that means this piece and this piece on the same line should be the same length. So let's say this whole thing was 10 inches. What would each one of these now have to be? The whole thing was 10 and I'm bisecting it. 5 and 5, good. So this would be 5 inches and this would be 5 inches, right? Doesn't matter what number you put, I'm just trying to show you, hey, they're exactly the same. Same with these two sides, right? These two would also be the same as well. Bisects cut in half. Okay, last part, consecutive angles. So consecutive, does anybody know what that word means? Right, like a second, like over and over and over again. So when you count consecutively, you count 1, 2, 3, 4, 5, right? You're counting right next to each other. So in this sense, consecutive means next to, or like in a row, whatever you want to call it. So angles that are right next to each other, right, or like in a row here, are supplementary. Do you guys remember what the word supplementary means? What does it mean? Adds up to 180. Good. Adds up to 180. Okay, and I know that this one has a lot of writing on it, but as we go through, you're going to go, oh, wait, you're going to notice a lot of similarities with the other ones. So supplementary means adds up to 180 degrees. So let's say that this, actually do the bigger one. Let's say this angle right here with the two arc marks was 100 degrees. If you have consecutive angles, that means right next to each other, right in a row. So the ones right next to it, boom, this angle right over here at the top is consecutive. They should add up to 180 degrees. So if this angle right here is 100, what does that mean this angle has to be? 80 degrees. Good. And then you should be able to mark all of the other angles. What would this one over here with the two arc marks be? It would be 100. It's the same as the other one with two arc marks. What would this angle over here with the one arc mark be? 80. It'd be the same as this one. So parallelograms are nice because it's a lot of the same thing. Yep. Go for it. All right. Once you got your quadrilateral, once you finish with that one, flip it over to the back. Okay. Now, the reason we're flipping over is because the trapezoid's like the kind of the weird oddball out, so we're gonna do that one last. So we're gonna go on to a rectangle now. Okay, so a rectangle is a type of parallelogram. It's a parallelogram. Remember, parallelogram means you've got two pair of parallel sides, and some sides are congruent as well. So rectangle is a parallelogram that has all, what type of angles are in a rectangle? What kind of angles are in a rectangle? What type of angles are these? They're all right angles. Good. So a rectangle is a parallelogram with all right angles. And that's important. Now, if it's a right angle, how do I mark that in my picture? What's the symbol for a right angle? The little square, the boxes. Good. So we're going to draw on our boxes. And then, hey, if you were to add up all those boxes, how many degrees are in a rectangle? 90 degrees. And then what would all of them be altogether? 360 degrees. Good. So in total, you're at 360 degrees. That's important to know. Okay. So rectangle is a parallelogram with all right angles. Opposite sides, so these sides here, they are both parallel and congruent. Parallel and congruent, and I need to mark them in my picture. So what's the marking for parallel? Flip back if you need to. What's the marking? Arrows. Good. So I'm going to do one pair of arrows and then two pair of arrows. Doesn't matter which one you put where. I just put the two at the top and the bottom because I had more space there. Okay, that shows they're parallel. What would show that they are congruent? Tick marks. Yep, the little lines. So I've got a line and a line for one side, and then I've got two lines for the other side. Again, doesn't matter where you put it on the side, to the right or the left of the arrows. Doesn't matter where you put it as long as it's somewhere on the side length. Okay, last part. Diagonals. So when I go from one corner to the other, one vertex to another, these diagonals, just like in a parallelogram, they will bisect each other, and they are congruent. So bisect means what again? Cut in half. Yep, good. And diagonal means you go from one corner to the other corner, from one vertex to the opposite vertex. So again, with our rulers, we're going to make our diagonals. Okay, and there we have my rectangle. Okay, now as you're finishing up that rectangle, here's what I want to do. If you were to look at that rectangle versus a parallelogram, so this is my picture from the front, that's my parallelogram, this is my rectangle. You should notice a lot of things are the same. What's something that you see that's the same between the two? Between this picture and this picture. What do they have that's the same? You tell me, what's the same between the two? Let's go in. Okay, good. They both have four sides. Good. What else is the same between the two? What's congruent? Angles and what else? Sides are marked as congruent, right? Angles are marked as congruent. Okay, what else? How many pairs of parallel sides are there in both pictures? Two pair. Yep, here's one pair, here's two pair. One pair, two pair. Now there's one really big difference. What's the really big difference between these two? Yeah, the angles of it. Yeah, the shape itself. One looks like straight up and down with 90 degrees. One looks like it's like tilted to the side, right? So the difference between the two really just is those 90-degree angles versus not 90-degree angles. That's the only really big difference between the two. Good. All right. FaceTime video. Okay, a rhombus is the next one. A rhombus, again, is a parallelogram. So again, you should notice parallelograms like the overall umbrella here. Rhombus is a parallelogram with all congruent sides. All congruent sides. Okay, so if it is a parallelogram, that means you have two pair of parallel sides. What should I put to show that the sides are parallel? Should put some arrows. Yep, so let's do that to start. One pair of arrows, two pair of arrows. Now, if all sides are congruent, what should I put on all four of the sides? How many? Just one tick mark on all of them. They all are congruent, so one tick mark on all of them. That's important. Okay. Opposite angles, so angles that are directly across from each other, are congruent. What do I do to show that angles are congruent? What's the marking for it? Curved line, yep, curved or arc. So one arc, two arcs. Opposite angles are congruent. Opposite sides, we already said this, but opposite sides are both parallel and congruent. Parallel and congruent. So I'm hoping what you're noticing right now already is this one looks almost exactly the same as the parallelogram one so far, right? Almost everything's marked exactly the same. The only thing that's a little bit different this time is our diagonals. Now, my diagonals are going to bisect each other. And you'll notice that that happens every single time. It's always going to cut them in half. But this time, my diagonals, are going to make a very special angle. So using your ruler again, let's make our diagonals. Let's see what you notice. And try to be pretty exact with this one so that you can see something important with your diagonals. Okay, if you look at those green lines now, my diagonals, what do you notice about them if you look in the center? What does it look like in the middle? What does it look like it's making? What kind of angle would be right in the center there? A 90-degree angle, very good. So in a rhombus, you've got diagonals that bisect each other and they also create 90-degree angles. And that means all four of these are 90-degree angles. If they create 90-degree angles, they are considered perpendicular. And I cannot put the whole word, so perpendicular. Create 90-degree angles. If we ever write down a word and you're not quite sure what the word is, I put a little vocabulary section at the bottom here for you. So congruent, bisect, supplementary, and perpendicular creates 90-degree angles. I tried to put that down there so that you would have something to look at. All right, so my diagonals bisect each other. They are perpendicular, and they also bisect opposite angles. So not only do they cut the segment itself in half, they also cut these angles in half as well. The last part is that consecutive angles that are right next to each other are supplementary. So they should add up to be 180 degrees. So again, if we look at the picture between a rhombus and a parallelogram, kind of hard to see, but there really is only like one big difference between these two. And what's the one big difference between a rhombus and a parallelogram? What's really the only thing that you see that is different? Should be one marking that you see and one that you don't see in the other. Not the tick mark. Oh, well, actually, yes, that is one thing, the tick marks. What do you mean? What do you notice? Uh-huh. Perfect. So in a rhombus, all four sides are exactly the same. In a parallelogram, you've got two pair of sides that have different lengths. Good, that's one difference. There's one more difference between the two. What about the diagonal? Good. In a rhombus, you've got a 90-degree angle there. In a parallelogram, you do not. So there's another small difference. A lot of the other things are the same, but you got two very small differences. Good. All right, last one. Hopefully, should be the easiest one because it's a square. And I'm hoping you know some things about a square. A square is a parallelogram with, what do you know about a square? What makes it a square? All sides are congruent. Perfect. So it's got all four sides congruent. All four sides are congruent. And what else makes a square? What kind of angles do you have to have in a square? All 90-degree angles, so all right angles. So let's mark those two things in the picture. If all four sides are congruent, what should you have on all four sides? Well, that's the angles. That's the angles, all right angles. I agree there. What shows that all four sides are the same? Oh, not an arrow. Arrow is parallel. Tick mark. Yep, a tick mark. Remember? So this one tick mark means all sides are the same. Okay. Opposite sides. So if you go across, these two sides are what? They are. What do you know about these two sides? The top and the bottom. It's not a trick. What do you know about the two of them? Are they the same or different? They're the same, so they're congruent. And are these two sides ever going to touch each other? At the top and at the bottom? Nope. So what is that called if they're never going to intersect? Parallel. Very good. So opposite sides are parallel. And all sides are congruent. We already have the marking on the picture for congruent. What's the marking to show that they're parallel? Daniel, you said it before. What is it? Arrows. Good. So one side has one pair of arrows. The other side has two. Maybe we need to make ourselves like a key. Tick mark means congruent. Arrows mean parallel. Maybe we should do that somewhere. That'd be helpful.
Yeah, but not today.
No, not today, but we can do it tomorrow. Okay, if you had to make a guess, what do you think happens with diagonals? They meet from point to point, and they starts with a B? Bisect. Good. They do. They intersect. Bisect is just another type of intersection. Yep. So diagonals bisect each other. My diagonals are congruent. And they do one more thing. So let's see. Let's take our diagonals. Let's draw them in. You might be right. diagonal, diagonal. Okay, what do they make in the center there? They make 90-degree angles. Very good. Right in the center. So they are congruent and they are perpendicular. Remember, perpendicular means they make 90-degree angles. So square has all four sides are the same, all right angles, parallel and congruent sides, and the diagonals bisect each other and are perpendicular. So square is probably like the most specific, but it's probably the easiest one to figure out. All right. We're going to do this little section right above that says classify it, and then we're going to go back to the front and finish trapezoid. So for each one of these pictures here, we're going to write down all of the classifications for the polygon. So that means we're literally going to go through each one of those four we just did and decide which one of those is it. It could be more than one. It can have more than one answer for our classification. So first of all, let's just start with the first picture. Here's my first one right here. Okay, everybody look at that picture. So first question is, how many sides does this picture have? Four-sided polygon. If it's got four sides, what do we call it? Give you a hint, it's the title. Quadrilateral. Quad means four sides. So this one is a quadrilateral. Okay, we start there, it's quadrilateral. Now let's go through each one. Is this a parallelogram? Is this a picture of a parallelogram? So does it have two pair of parallel sides? Yes or no, show me with your thumbs. Is this this? No, definitely not. Does not have two pair of parallel sides, right? Everything's intersecting. Okay, so it's not this one. Let's go to the next one. Oh, not a trapezoid. They said we weren't doing that one. Is this a rectangle? Definitely not. Is this a rhombus? No? No, it's not. And is this a square? No, so guess what? That's it. That's your whole classification for that one. You're done. It's only a quadrilateral. It's nothing else. Let's go to the next one. How many sides are in this picture? Four. What can you call this one for sure? Well, before you get there. Quadrilateral. So it's definitely a quadrilateral. Let's start there. I'm not going to write the whole word. I'm just going to put quad. Now, what do you notice about this picture? It's a square because it's got what? It's got 90 degrees. It's got all four sides are exactly the same. You know for sure this one's definitely a square. But let's make sure it might not be other things. Is this one a parallelogram? Why not? Why do you think that? Ooh, does this say it has to be that though? It just says opposite sides are parallel and congruent. Are your opposite sides parallel? Yeah. Are they congruent? Yeah, they are. They're all the same, right? Also, don't forget too, if you look at the definition of the square, a square is a parallelogram, right? It is a parallelogram. So you also have to write down parallelogram. All right, let's finish the other two. Is this a picture of a rectangle? So do you have all right angles? Yeah. Do you have opposite sides are parallel and congruent? Yeah. Do your diagonals bisect each other? Yeah. So is this also a rectangle? Yes. Yes, I do. Yes, you can. So this one's super specific, isn't it? Last part, is this a rhombus? So is it a parallelogram with all congruent sides? Yes. Are the opposite angles congruent? Yes. Are the opposite sides parallel and congruent? Yes. Do they bisect each other, the diagonals? Yes. And if I were to make them diagonal, would they create a 90 degrees in the center? Yes. So this one is also a rhombus. Wow. So that one's super specific because it's all types. All right, last one. Is this a parallelogram? Does it have two pair of parallel sides? So does this look like this? And are opposite sides parallel and congruent? Yeah. This picture looks exactly the same as this one. This is a parallelogram. I'm not going to write the whole word. Is this a rectangle? Why not? Doesn't have right angles, so this cannot be a rectangle. Is this a rhombus? Does this picture look exactly like this picture? Do you have all congruent sides? Yes. Do you have opposite angles are the same just by looking at them? Yeah. Does this picture look exactly like this picture? Yeah. This one's also a rhombus. Okay, last but not least, is this one a square? Why not? There's no right angle. So this one is only a parallelogram and a rhombus. Actually, it's a lie. It's one more thing. What should I have put first? A quadrilateral, yeah. Should have put that first. Good. All right, questions on that one? We're done. 56, perfect. All right, we got just enough time to do our final one, which is trapezoid. Back to the front. Okay, I did trapezoid last because it's kind of a funky looking one. A trapezoid is not a parallelogram. So that's why this one I decided to do by itself on its own. A trapezoid has exactly one pair of parallel sides. One pair of parallel sides. Only one pair. If you were to look at this picture, which ones are parallel? Yep, top and the bottom. So what should I put on them to show that they're parallel? An arrow. So that's it. Your only pair of parallel sides are the top and the bottom. Now, the two that have the parallel sides, these are called the bases. So this is called base 1, and this is called base 2. Base 1. Okay, we put a B with a little 1 next to it to show that it's base 1, and then a B with a little 2 next to it to show that it's base 2. So your bases are the ones that are parallel. To find the mid-segment of a trapezoid, you will take base 1 plus base 2 and divide by 2. So I'll show you what I mean. Base 1 plus base 2 divided by 2. Now, what does the word mid mean?
Halfway.
Halfway. It's right in the middle. So if you look at the picture of your bases, right, here's the top, here's the bottom, I'm going to draw a line that's right in the middle, or to the middle to the best of my ability. That's called the mid-segment. Yeah, it's right, it's halfway. It's like a midpoint. It's right in the middle. So to find the length of that mid-segment, I would take the length of the top one plus the length of the bottom one, and then I would divide it by 2. In other words, I'm finding the average. So let's say, for example, that the top length was 10 inches. And let's say that the bottom one was 20 inches. And I want to figure out, okay, what is the mid segment? So I would take my top plus the bottom, and then I divide by 2. So what's 10 plus 20? 30. And then what's 30 divided by 2? 15. So your mid segment would be 15 inches. That's it. So we did 10 plus 20 divided by 2. And that's how we got our mid segment of 15. That's it. Super simple. It's just finding the average. So you've got your base at the top, a base at the bottom, the other two sides here. So this side on the left and this side on the right. These are called the legs. So you've got bases at the top and the bottom. You've got legs on the two sides. Consecutive angles of one leg. So the two angles on this green line are supplementary. And supplementary means what? Adds up to 180 degrees. So what I mean is this. If I were to tell you that this angle up here is 100 degrees, what does that mean this angle down here has to be? 80 degrees. Good. In an isosceles trapezoid, the legs are congruent. That means this angles and these side lengths would have to be the same as these angles and this side length. So if I just essentially take this and flipped it over to this side, what would this angle on top be? It would be the same as this one, which is 100. And then what does that mean this angle down here would have to be? 80 degrees. Good. Nice, nice, nice. Okay, so tomorrow we are going to do practice with, we're essentially doing one day practice for each one of these. So tomorrow we'll do parallelogram. The next day we'll do a trapezoid. The next day we'll do a square. The next day we'll do a rectangle, right? We're going to do essentially one day of each practice for each one. So do not lose this paper because this is your reference sheet for the rest of the chapter. You should take it, put it directly into your binder right now. It should be the third paper in your binder. You do not have any homework tonight unless you didn't finish your homework from Friday. Your homework from Friday was this. 6.1 interior and exterior angles. It had this on the front, and then it had a whole bunch of algebra problems on the back. So if you did not finish that on Friday, that is your homework. It closes tonight at midnight. So if you didn't submit that, that is your homework. But if you already did that homework from Friday, you don't have to worry about anything tonight. Yes. Yes, it's up front. It is in the 22nd if you missed Friday. That's your only homework. But if you are already on task and you already submitted it, then you have no homework tonight, which is great.